Hi everyone, and welcome, and thank you everyone for coming. My name is Erik, and I work at Oracle, and today I will talk to you about modules in Java 9. And before we start, I want to show you this slide. I'm going to leave that hanging out there for a few awkward seconds while you enjoying it. Essentially, don't take my word for everything I say, don't really trust everything, and don't base your future business decision on this talk. So who am I? I worked with GC and the JVM for actually more than 5 years now. I have worked with Java and GC for the last 2 years. I worked with Metaspace, I worked with diagnostic tooling, the trace framework, build tools to make files, testing, etc. Lots of stuff all over. I work on OpenJDK. That's my daily job. Now you might be wondering, why is this guy talking about modules and language stuff? He seems more like a JVM engineer. Fortunately, I do have a Master of Science in Theoretical Computer Science with a focus on formal methods. And those fancy words is just academia for I love programming languages. I have approached modules the same way that you will be learning about them. I have read the JEPs, watched Java 1 presentations, and also played around with the JDK 9 early access builds. And before we dive into the presentation, if you have any questions, please raise your hand. If you're thinking I'm not really following along, I don't get what he's saying, just stop me and we'll talk about it, because there's a big chance that more people in the room aren't really getting it, and I'm here for you guys, so just raise your hand. I have a little bit of a hard time seeing you, because I have a cinema projector right in my eyes, but I will try my best. So whenever someone comes up to me and tell me, look Erik, I built this shiny new big feature, the first thing I usually say is, awesome, that's great. And my second thought is, but why did you build it? So I would like to start with looking a little bit into history and what problems are modules solving. They actually solve a lot of problems, but I'm going to be focusing on 3 problems today, and that's the class path, so-called internal packages, and also the size of the JRE itself. So, the class path. I did some reading on Wikipedia and came across the not so nice term jar hell when browsing through class loaders and the class path. What is jar hell? Jar hell is a term similar to DLL hell, used to describe all the various ways in which the class loading process can end up not working. Well, that's not particularly nice, so let's dive into this a bit. So first, some definitions. A class loader is responsible for loading classes into the JVM. The class path is a list of directories containing class files, and they are potentially bundled up in jar files. And the application class loader is responsible for loading classes found on that class path. So looking at an example, you guys are probably all familiar with this. We have a Java invocation with a class path containing 2 jars. We have the utils.jar and the stuff.jar. This is a great application. And we're running the main program. Looking at this scenario, in utils.jar we have 2 packages, utils and misc. In the utils package there's a util class, and in the misc package there's a misc class. Looking in the wonderful stuff.jar, there's a stuff package with a stuff class and also a misc class. Now when this program is running, the main class is going to reference other classes that will in turn get loaded. And we're going to focus on this fellow over here, stuff.class. So what happens if main wants to reference stuff.class and try to load it dynamically into the JVM? Well, the stuff.class refers to misc.class. It uses a misc object, so we have to load the misc class as well. And now there actually is a slight little problem here. You see, we have the package misc in utils.jar with a misc.class, and there's a package misc in stuff.jar with a misc.class. So when the JVM is going to look, okay, stuff is going to need misc, and it's going to search the class path described above, what is going to happen? Some of you might have encountered this scenario. It's not fun when you do, because what will end up happening is that the misc.class from utils.jar will get loaded. That was not our intention, but due to the class path that utils.jar comes before stuff.jar, the application class loader will read the class path in order and just load the first class with the correct name, and that name includes the package and the class name. So this is a bit surprising behavior. You wanted stuff to use this misc.class, but it ended up with some completely otherwise misclassed class that you might not even know about. So in this little example, we could probably have detected this problem. I mean, there were two packages, two jars involved, 4 classes. We could have just scanned through it and realized that, oh darn, I had a little issue here, let's fix it. But in the real world, class paths looks more like this. And here it's a bit, this is actually just 1/3 of a real class path. It would have taken 2 more slides to show the whole thing. And now it becomes a little bit harder to try to figure out if there is any conflict in here when loading classes. And it's not only that. What happens if you forgot to add a jar to the class path? Maybe someone made a typo in the Maven POM, or someone mistyped in the Gradle build configuration. You will get a class not found exception when the class loader tries to load the class. And this is lazily done and dynamically, so it could be done after 1 week of uptime in that error handling code. This is not a nice surprise. So those were 2 problems with the class path. Now we're going to look at the internal packages. So we have another little example here. We have a library.jar with a package utils, a package stuff with our trustworthy utils and stuff classes. Now utils, you added some more utilities, so you added your MISC class. And after a while you find out that stuff also needs a MISC class, the same actually. You need the same code in both packages. But now you have a little problem. Either you copy and paste, you don't do that, the MISC class into both packages, or you're being a responsible good developer and you refactor out the MISC class into its own package MISC with the MISC class, so that utils and stuff can both share the same implementation of MISC. Now, however, we have a slight issue. You're going to have users of your library, and they will use whatever they find, essentially, in your little library. So they will find the package utils. That's good. You want them to do that. They will find stuff. But they will also find the MISC package, and you didn't really intend for them to use that. That was more like an implementation detail of your library. I mean, you don't want to provide backwards compatibility with MISC. You might not even need it in a few days. You might want to refactor, rename things. You don't want to provide API compatibility with many future releases. So what usually happens is this. You rename it to internal. It's still going to be publicly available for anyone using your library, but you try to set up a sort of gentleman's agreement that please do not rely on this package. The implementation might change. There are different words for this. You see internal packages, you might see unsafe packages, you might see private package or something else. But is this a problem in the real world? And yes, it is. Looking at just 3 examples in Guava, you have the package com.google.common.base.internal. In Hibernate, you have org.hibernate.validator.internal.engine. In Apache Commons RNG, you have org Apache Commons RNG.simple.internal. In all this Java doc for all these packages, it clearly says do not use this package. This is intended for internal purposes for this library. But there's nothing stopping you from it, and if the developers of these libraries wants to be really nice, they try to provide backwards compatibility, but there is nothing forcing them to do it, and you can't rely on this package. Essentially, the developers of these libraries probably would like to hide this at all, so you don't get to it. And finally, we're going to look a little bit at the size of the JRE itself. So the Java runtime environment contains a fairly big standard library. And this is great. We get lots of well-maintained, high-performance code that's ready to use, ready to go, supported. But where are these standard library classes stored? Because there's quite a few of them. If we bring up a little terminal and take a peek into our JRE, we find the usual directories, bin, man, plugin, lib, release. Looking at the size, that's a pretty big JRE. And what's more, we can take a peek inside a lib directory, and we'll see, oh, there's our jar files with the standard library classes, and most of them end up in rt.jar at the bottom, and that's 64 megabyte. That means that if you're just going to write a little simple systemout.println hello world, you're going to have to drag along those 64 megabytes of standard library classes, because you need rt.jar to run your program. This is a little bit like an all or nothing approach. It's hard to get the pieces you need just for your application. You either get it all or you don't get it at all. So, these were the, oh, there's a typo. Class path, internal packages, and the size of the JRE itself. So keep these in mind, because now we're about to enter the world of modules and how they solve these problems. Now, modules is a new feature for Java 9, and in this talk, I'm talking about modules as in the Java platform module system. There are other module systems out there, but this will focus on the Java platform module system. So modules, what are they? What is a module? So you are Java programmers, you are used to grouping your fields and methods into classes and interface. Those classes and interfaces, you group them into packages, and now you group packages into modules. So looking at a bit more visual representation, you are used to having your lines of code grouped into methods. Those methods are grouped into classes and interfaces. Those classes are grouped into packages, and those packages will now be grouped into modules. So looking at some code, there's a single line of Java, a Java statement, return x plus y. You usually group that into a method, such as add. That method will be grouped into a class, like adder. You probably put that in a file called adder.java. As you get more and more classes, you will create a little package. Here we have the package com.acme.calculator. And as your little project grows, your little library, you package this up. You get more classes. You might have a divider, a multiplier, a subtractor, and adder. All part of the com.acme.calculator package. At this point, you probably want to provide some documentation for your little library. So, then this is usually what it looks like on disk. If you look inside your source code directory, this is the convention that I guess most of you follow for your Java applications. So, how many know about package-info.java? Yeah, I see a few hands. Package HTML. Anyone package-info.html? No? Okay, so since JDK 5, there's a nifty little file called packageinfo.java. In that file, you can add some Java documentation for your package, which is great if you want to provide some introduction to your package. You can also provide package level annotations, but we won't go into that. And you can also type out the name of your package. Now, as your little library grows, you might add a few more packages. You have the com.acme utils, com.acme calculator, consisting of just regular Java classes. You might add a package-info.java if you want to provide some Java doc. And now is the time to have a look at the source code for this. This is a directory structure you are all, again, familiar with most likely, how you organize your source code. And now when you add a module, where do they end up? How do they look? What do they consist of? So your module will end up in a module-info.java. And what does a module look like? Well, we can just cat it and see. And here we go. We have a module. It has a name called com.acme.calculator. And that's all there is to it for this little library, actually. Don't get confused. There's a package called com.acme.calculator, and there's a module called com.acme.calculator. There's a difference between those. We'll get into later why the naming. This will most likely be the naming scheme many of you will end up using, and we will see why later. But this is all there's to the module for this little library. And if you look at the source code, things have moved around a little bit. Again, this is not mandatory, but it's likely that many of you will organize your source classes like this for a modular library or application. You have your source directory. You have a directory with the name of your module. This is not required, but it's likely that you will see later also why this is a convenient way of organizing your source code. We find the module-info.java here at the bottom. And then we have the usual Java package structure for our source code. Now, what goes inside this module-info.java? This looks very empty for being such a big feature. Actually, when you don't type anything besides the name, you will get one little thing for free from the Java C compiler, and that is requires java.base. So this is a new concept. What is requires? What does it mean when a module requires another module? That means for the module com.acme.calculator to work, it says I require the java.base module, otherwise this module will not work. So if you think of it as a little graph, we have our com.acme.calculator module requiring the java.base module. Now what is java.base? We haven't really seen that before. Is this like the rt.jar? Is it something else? Well, in Java 9, the standard library has been split into many multiple modules, and it looks something like this. This is just part of the module graph for the Java standard library, but here at the bottom we see the module java.base. So this is using the same module info files that you will be using when you write modular applications. So there's a module info file with a module name called java.base here at the bottom. This contains stuff such as java.lang.string, java.lang object, things that every running Java program needs. Otherwise it hardly wouldn't be a Java program. But we can also see some other modules in here. We see that, okay, logging depends on, requires java.base, of course. We can see that SQL requires java.xml module, the java.logging module, and they in turn require the java.base module. If you take a look at the top, we see the java.se for standard edition. That requires compiler, desktop, java.security.jgss, Java instrument, management, security SESL, quite a few modules. But this is now what the standard library looked like in a modular way. So again, this is the little project we're having, our calculator library, with the module file that requires java.base. And after you work with this for a while, you realize I don't really need my own logger.java class in utils. I can just rely on Java util logging. So let's get rid of that. But now recall from that graph that java.logging was in another module, so we have to add requires java.logging for our application to work. Now, what if some other application wants to use the little library we just created, the com.acme.calculator module? Should that application or other module library be allowed to use the com.acme.calculator package? Yeah, that seems reasonable. After all, that's the reason we made this library at all, to bring the world the functionality of adder, subtractor, divider, and multiplier. Should it be allowed to use the com.acme.utils package? No, that doesn't seem necessary. That's an implementation detail for our module, where some things we just use internally. And the way we express that in the module info file is that we add a line stating that we export com.acme.calculator. So you see requires takes the name of a module, but when you export a package from your module for other modules to use. And you can also add comments, and here we have a comment saying very explicitly, we do not export the package com.acme.utils, and since we haven't written an export clause for com.acme.utils, no other modularized applications or libraries can get access to that package. The other modules can only access packages that we export. So, to recap a little bit, you require other modules that your module depends on. You export packages from your module for other modules to use. If you just remember these two key concepts, you're off to a very good start with the Java platform module system. But we're going to dig a little bit deeper into all this. So modules are described by your module info Java files. In that module info.java file, you name your module, you require other modules that your module depends on, and you export packages for other modules to use. But how are these modules compiled and executed? I mean, this is the kind of file we haven't really seen before, so how do we work with it, like getting it something to ship and run? So modules are described in module info.java files, and as for all Java files, we compile them with javac. So this is our modularized library, our calculator library that's going to take over the world, get so many stars on GitHub. We had the two packages, calculator and utils, and this is our module info.java that we looked at with our requires and our exports. Now when we compile this, we do it as usual with javac. So you have javac-d for classes. I'm just going to store the class files in a directory called classes. And then I need to provide the Java files to javac, so I use a little find command there to get a listing of all the source files. We will end up with a directory called classes after running this. Yeah, this looks like normal class files from a normal Java application, with the exception that we now have a module info.class in there as well. If we want to bundle this up so it's easier to share with others, to ship around, to move around, we will use the tools that you're already familiar with, such as jar, to bundle this up into a so-called modular jar file. So you use jar -create -file, and this is where we build it up, lib calculator.jar, and tell jar that it will find the classes in the classes directory. So the only difference here between a modular jar file and a regular jar file is the presence of module-info.class. And if we take a look, yeah, we see we got a normal jar file in there. So how are modules executed? We only seen how we compile our library into a jar file. So let's add a main class to our library so we can run it as an application as well. We're actually going to do a little bit more. We're going to add a new module, com.acme.main, with one package, com.acme.main, with one file, main. So this is the source code laid out as it is. And when we add our new module with our new package, with a new Java class, it looks like this. So it barely fits on the screen. But now you start to see the reasoning why I mentioned that putting your modules in a directory with the module name starts to make a little bit more sense. Up at the top here we have the module we've been working with so far, com.acme.calculator, our library. And down here we have our new main module, com.acme.main. As usual, the package directory structure with the main class in there. And we also have a new module info for this module. So what does the module info look like for the main module? It's pretty small. We give the name, com.acme.main, just as the same with com.acme.calculator. But now we have to tell the module system that, hey, we require com.acme.calculator for this module to run, because we're going to use functionality from com.acme.calculator. So just add that requires clause. And as usual, we get requires java.base for free. We don't have to type that. We can type it out, but it's not necessary. So if you want to compile this, you again use the tools that you're all familiar with. In this case, Java-C for compiling. But now I'm just going to tell it to compile the main module alone. I won't compile two modules at the same time. That will actually be an error. You compile them one at a time. And again, oops, what happened there? I told you should just compile as usual. It should just work, but it didn't work. Oh, am I lying over here? No. Let's look into this a little bit more. Error, module not found, com.acme.calculator. Requires com.acme.calculator 1 error. Okay. So it seems like Java-C did not find our com.acme.calculator module. But why did it work when we compiled that module? Well, com.acme.calculator, that only relied on java.base and java.logging. Those were in the JDK, so we just sort of, Java-C knows how to find those modules, but it doesn't know how to find com.acme.calculator, so we have to tell it. We're going to add the argument --module path to Java-C and say, you know, if you encounter any modules that you don't know where to find, have a look in this directory, and you can pick them up. Remember, we put our calculator.jar in the lib directory, and now it works. And now we can also bundle it up into a modular jar file. So our main module will also end up in a modular jar file. So we do jar -create -file lib/main.jar, and we specify a main class. This is the same as we used before. We're just going to tell, like in the manifest file, there's going to be an entry stating that this is the main file with this is the class with the main method, if someone intends to run this. And we tell it where to find the classes. And now in our lib directory, we have two files, calculator.jar and main.jar. And you go, great, Erik, you managed to compile everything, but how do I run it? Can I finally run my modularized application? Yes, you can. We use Java, again, the same tools you all know and love for running the application. Java, and now there's a few new flags to the Java launcher. We have a -- module path. This is the same as for Java-C. We need to tell the Java launcher where to find our module files or our modules. But we're also specifying -m, which module we want to execute, and we're going to run the main module. And remember, we put in the jar file, we added in the manifest the main class attribute, so it knows where to find the class with the main method. And then just the arguments to our calculator. And we get the output free. Great, it seems to work. But what is actually going on? Remember, look, if you look at this slide, we only told Java, like, run our main module. We didn't specify any other modules we need. We didn't list all the packages on some kind of... The module path is just a directory. How did Java find out which modules were required by com.acme.main? Well, during initialization, Java will take a look at the module file in com.acme.main, and com.acme.main required com.acme.calculator and java.base. So it will load those two modules, and then in turn, which modules does com.acme.calculator and java.base require? Well, java.base is sort of the sentinel here. It doesn't require anything. It only exports packages. But com.acme.calculator required java.logging and also java.base. But java.base is already loaded, so we don't have to do that twice. And the java.logging requires java.base. But again, we already loaded java.base, and now we have a complete little module graph for our application. So let's play some tricks with Java here. I'm going to be a bit sneaky, and I'm going to remove our library, the calculator.jar, and then try to run Java again, specifying that the lib directory is where you find all the modules you need that you don't know of. What do we get? Oops. We get an error. It says, error occurred during initialization of boot layer. Java lang module find exception. Module com.acme.calculator. Yeah, that's the one we removed. Not found, required by com.acme.main. Okay, and the key word here is initialization. You will not get this after 1 week of uptime in your error handling code. You will get this immediately when you start your application. It will tell you, look, something is wrong. There is a module missing, and I might not be able to load all the classes I need to run this application. So this is great. At least I prefer to find this out sooner rather than later. So there's a few key properties of this module graph that we actually can make use of a little bit more. Remember the module graph we had for our application? There's a new tool in JDK 9 that uses this module graph called jlink. So jlink says in the documentation, you can use the jlink tool to assemble and optimize a set of modules and the dependencies into a custom runtime image. Wow, that's a lot of words. Shorter, create your own JRE. So let's have a look. What does this mean? So the application consisted of two modular jar files. We had calculator.jar and main.jar, each one containing our modules, com.acme.calculator and com.acme.main. But there's a whole bunch of modules, as we saw from that big graph from the JRE itself. There's actually, if you take a look inside the jmods directory, there's 96 modules in there. But we only needed two modules for our application. We only needed java.base and java.logging. Why do I have to keep to drag around 96 modules when all I need is two? That seems a bit inefficient. So, enter jlink. And jlink is a new tool in JDK 9 that makes use of the object graph. And you can describe to jlink, here's the module path. Again, you recognize the module path from Java-C and Java. Specify to jlink, this is where you will find modules. But now we actually have to tell it about the JRE modules as well in jmods and the modules from our application. You tell jlink that I want to add the module com.acme.main, and then you figure out the rest, what is needed to run this module. We will also add a little nifty launcher. We will see what this is. We're going to say that I want a little launcher called calc that corresponds to running the module com.acme.main. And you can output all this into a directory called JRE. So let's have a look inside that directory. Oh, this looks pretty much like a regular Java runtime environment. We have the bin directory, we have lib, and this has been restructured since JDK 8, but this is sort of a very small but normal JDK 9 JRE, just configured explicitly and particularly for our application's needs. And if you look inside bin, oh, look there, we found a little launcher. There's a calc program that you can run inside there. Let's try to run it. And it actually runs our little application. That's pretty sweet. But the really, really cool thing about this is that if you start to look at the size of this JRE, how does it compare? Remember, our Java 8 JRE, that was almost 200 megabytes. This is 45 megabytes. So that's quite a bit smaller, but still it's pretty big. So I'm gonna just add on a couple of more flags to jlink and tell it to, shrink down that size. I need a smaller JRE. I'm gonna tell it to zip all the class files. I'm gonna tell it I don't need the man pages for this. You can skip the header files as well. Strip the debug symbols. Let's get rid of all the luggage here. And then output that into the JRE directory. Now we're down to 30 megabyte for our JRE. Can we go further? Yes, if you have a minimal VM. I've seen Mark take this down to 15 megabyte for a simple Hello World application. And this is a huge difference. We're talking about like 15 to 30 megabytes instead of 200 megabytes. Now, like in this day and age, you think that many people, everyone has fast internet connections they can download, drivers and disk is cheap. But if you're targeting smaller devices, like IoT devices or your Raspberry Pis, this is a big difference. And also, if you guys are starting to deploy your microservices in your Docker containers and whatnot, you probably want to bundle up your JRE along with them. And now you just shrink your size quite a bit for that Docker container. So to summarize this and wrap it up a little bit, the modules are described by module.info.java files. In those module.info.java files, you will require other modules that your module depends on. You will export packages for other modules to use. You will also name your module. And as usual, the tools you know and love, you compile with Java-C, you bundle it up with jar, and you run it with Java. And new for JDK 9, you can now create your own JRE with jlink. So what about the problems we talked about in the beginning? Did we solve anything, or was this just a cool new feature? Well, looking at the class path problems, we now get exceptional startup if the module isn't present. So that problem seems to be taken care of. Remember, we also had that problem with two packages with the same name, and I didn't show that on the slides, but you will actually get an exception if the same package is found in two modules. Looking at the internal packages, well, we now know how to solve that. We will just not export the internal package from our module. And finally, the size of the JRE. Well, now you guys know that you can just use jlink to create a custom JRE that is much, much smaller. But you're saying, Erik, I still want to learn more about this. Well, there are 5 excellent presentations on YouTube. From Java 1 2016 about the module system. You have Prepare for JDK 9, Introduction to Modular Development, Advanced Modular Development, even more modules and services, and finally, if you want to go all the way, Project Jigsaw under the hood. Knock yourself out. There's lots of stuff to learn in these presentations. If you prefer reading, you can have a look at the documentation at openjdk.java.net/project/jigsaw. And the most important thing, download and try out JDK 9. There are early access builds available. Try to download, try it out, create a few modules, hack at it, see if it works. And if something doesn't work, then please come and talk to us. So thank you very much. And I think we have quite a bit of time for questions. There's a mic coming.
Thank you. Yeah. You showed an example of how to compile this with Java-C and jlink and whatnot. As a normal person, I don't use those tools in my day-to-day life. So what would be my workflow using, say, Maven or Gradle? And will the project structure be the same, like the recommended project structure as you showed, or any comments on that?
Yeah, I don't know the recommended project structure, I'm not sure, but Maven is running fine on Java 9 and JDK 9, so if you're using Maven, just try it out. I know that Gradle have a few small kinks to work out, nothing major, but they're working on it. So Gradle is soon going to work as well, and again, it's the same as with packages. You can lay them out in the usual directory layout, or you can make your own. It depends on what you prefer. But yeah, having them in the directories with a module name seems like a good solution, to me at least. More questions over there in the middle?
Hi. Let's say I now want to convert my project to use Java 9. What happens to those dependencies
Great question.
that are not compiled using Java 9?
Yeah, that's a great question. So there's a feature called automatic modules, and I'm sorry, I only had 45. As you saw, there were 5 presentations from Java 1 2016 on modules. I tried to cram as much as I could into one session. But there are ways in which jar files can automatically be recognized as modules, and all the packages in those jar files will be automatically exported. Please look it up in those videos or in the documentation at Project Jigsaw. I think there's a question. Oh, yeah.
You showed that you can have your own small GRA. How is memory usage changed also? Does it affect or not?
So the memory usage, well, that's me. I make the garbage collectors. No, remember, one of the cool things about Java, and that we also had a slight problem with in the beginning, is that loading classes is done lazily and dynamically. So you don't, as during the runtime, there are some optimizations possible, but they're not that utilized at the moment. But during runtime, even if you have a big standard library in that rt.jar, you will not load all the classes. You only load the classes you need. So even though it takes up quite a lot of space on disk to ship it around, when your process is actually running, you only load the classes you need.
My question is if it is possible to have multiple versions of a given dependency in the dependency graph.
So I think the question is, what if a module, if there, let's say that one module bundles up, I don't know, Guava 18, and another module bundles up Guava 21.
Yes, exactly.
Is that possible? And what? No, that will be an error when you're starting up the module system, and we can we can have a long and interesting discussion about whether you should or should not have multiple versions of the same library. Is that a good thing or is it a bad thing? But right now you will get an exceptional startup stating that you cannot have 2 packages, the same package name found in 2 different modules.
Okay, thanks.
Java's strength is in cross-platforming. Is it a step back? Can jlink make JRE in Windows for Linux or not?
That's a very nice question. I'm not sure actually. I have to refer you to I haven't tried it out. I mainly use Linux, but please have a look at the jlink documentation. It should be noted in there. Oh, there's a question in the front.
Hi.
Hi.
One question about future, basically. What happens with the recent veto, no, but voting on Jigsaw inclusion in Java 9?
Oh yeah, that's a good question. We should provide some background here. So whenever you make a specification change, and this does impact the specification of what Java means, there is a process called the Java Community Process, or JCP for short, where you have, and this is a little bit different from OpenJDK. The JCP was established prior to OpenJDK. And you can make your JSRs, a Java specification request, where you detail the changes you want to make to the specification. And then there's an executive committee voting or approving your specification request. And quite recently there was a no to the JPMS, Java Platform Module System, but no as in there will be another vote in 30 days. I will encourage you to read up on, because all the communication around this is public. There are mailing lists from the JCP where you can find out more exactly what, because there are a few minor details still being, they are discussing, and it's pretty cool, at least to me, to follow along and see all the experts like talking about it and coming up with different solutions on how to approach the problems. So I encourage you to read the mailing list to get the latest.
Remember you told that you won't be able to compile with the same version of the dependency, like if we use Guava with different versions. What happens if we use 2 libraries which have the transitant dependency on different versions of Java. The project won't be able to compile it all.
So there's a slight difference here between what happens during compilation and runtime. During compilation, as we saw on some slides, you can compile the modules one by one. And there Java-C, depending on how you compile it, might not see the conflict during compilation, but it will definitely see it during initialization when you start it up. So in a modular world, Guava will become a module eventually, and then you will depend on that module, and there won't be a problem with the packages. But for now, if you have Guava in 2 different modules, you cannot have different versions, or you can't even have Guava in 2 different modules. There will be a package conflict. But there are workarounds to that. If you have used shading before, maybe you can shade in one of the modules. But again, please remember that there's a difference between converting an existing application to modules and once there's sort of a modularized world. Ideally, Guava would be a module that you could just require, and that will work. You don't have to have the Guava package in 2 different modules. Yeah, question?
Hi, don't you think that this jigsaw thing might become to Java what Python 3 to Python 2?
Yeah, that's a good question. Many people are worried about backwards compatibility. Please remember that I showed you the module world. The class path is still there and will always be there. Your Java application, if you have an application running on 8, it will most likely just run on 9. It's not like we forgot about backwards compatibility in this release and made sure that nothing runs. I mean, download JDK 9, use the class path. There's no need to rush into modules or, having everything modularized at the get-go. You can just run your Java applications normally using java-cp and specifying -jar with your jar file. A regular Java 8 jar file, of course it works, otherwise it wouldn't be backwards compatible. But yeah, thanks for clearing that up. That's important to remember to say.
Will there be different versions of modules?
Will there be different versions of? You mean if you have 2 modules, like modular version 1 of one module and version 2 of another module?
No, or you have one module, you release that module, and then people use it. Then you make some improvements and release another version.
So for the Java Platform module system, it does not consider versions. You only specify the name of your module. Then there are existing tools like Maven, like Gradle, like Ant, that have various ways of saying, look, I rely on module version or a jar file version 2 with a module over here and another version over there, and how to resolve those conflicts is left to the tools that do it so good, like Ant, Maven, Gradle.
Still question here?
Yeah, I have one question,
yeah?
But I probably know the answer, but I think it's a good thing to cover here. So you had 2 modules in your example. One is using another, but you didn't tell what will happen if one module wants to access the other reflectively.
Oh, yes, I didn't have time. Again, there were 5 talks at Java 1 covering modules. I had 1 session to try to cover as much as possible for you here today. There are a few changes with regards to reflection with modules. By default, in a module, another module can only reflect on the exported packages and therefore publicly accessible types. If you have, for example, packages like the utils package we saw that we did not export, that will not be available for reflection by default. You can open up your module by typing another keyword called open in module info Java, saying I'm opening up my module with all the types for reflection for either all modules or for a particular module.
Question from my side.
Yeah.
Will you be able to open jar and still load class, let's say manually, or JVM will prevent it from doing like that?
No, as I said, the class path is still there in 9. It still works as in Java 8. Your programs will work on 9. So yes, the class loading mechanism is essentially unchanged with Jigsaw. Jigsaw uses the modules do not make use of class loaders right now. They behave almost identically as in 8. Yes, that's a yes. Good technical point. Yes, the hierarchy for the class loaders have changed. If you're into that. So I will of course be around if you have more questions. I will be here at the conference today, and I think there's some kind of Q&A session on the 6th floor immediately afterwards. But thank you so much for coming, and please try out Java 9 and JDK 9 and have a go at it.